Hello everyone, I hope you are well. Welcome to our lesson on resistance. Now before you see this video, you should have plotted a graph of length of wire against resistance. So if you have not done that, please go to Google Classroom. There are two pictures attached, one of the results and one of the graph paper, and please go draw that graph and then come back and join us here. If you have done the graph, let's crack on with today's lesson. So the first thing we are going to do is a few practice questions based off an equation we have seen previously. And that equation is, my Apple Pencil does not have any charge, so I'll just charge that whilst we talk. The equation is Q equals, yes I know it's got no charge, Q equals IT. Q is charge, I is current, T is time. So if you can please pause the video and have a go at these practice questions, and then I shall go through the answers. Okay, assuming everyone's had a go at those practice questions, let's go through answers together. Let's hope my pencil is charged enough. Question number 1, you're working out charge. So you are going to do current times time each time. Q is I times T. So current of 10 flows at 20 seconds. Come on. Oh, helps if I press edit. Yes, there we go. Woohoo! Now let's just make it thinner. Okay, so 10 times 20 equals 200, and it's charged, so it's measured in coulombs. Number 2, current 15 amps flows for 3 seconds, so 15 times 3 equals 45 coulombs. Current of 20 amps flows for 1 minute, that's 20 times 60. Remember that 1 minute needs to be turned into 60 seconds, so that's 1,200 coulombs. Calculate the current flowing in an electric circuit, so I'm working out current, which is Q divided by T. So you've got 20 coulombs over 10 seconds, so 20 divided by 10 is 2, and it's amps because it's current. I is 0.5 divided by 5 equals 0.1 amps, and 100 divided by 60 is 1.6 occurring, so I'm going to round it to 7 amps. Question 3, a lamp uses a current of 2 amps. So I is always there. What time must be switched on for? T is Q over I. So 50 divided by 2 equals 25, and it's time, so it's seconds. 75 divided by 2 equals 37.5 seconds, and 100 divided by 2 equals 50 seconds. Okay, so if you can please now title and date. It is not the 23rd of September 2019, so please write whichever day you're seeing this, and then let's go on with our notes for today. So, resistance, our concept for the day, effectively is how hard it is for the electrons to flow through a material. A high resistance, like an insulator, slows them down, and a low resistance, like a conductor, allows them to travel fast. And it is measured in ohms. So that OHMS is ohms. It's named after a French scientist, which we'll see in a moment, Georges-Simon Ohm. And its symbol here is actually a Greek letter. Now, its official name in the Greek alphabet, not here, is omega, but we refer to it as ohms. So just like that, like a little head and shoulders there. So ohms. So here we go. Here's Georges-Simon Ohm. He came up with a law. Now in A-level you'll learn it in word form, but for the time being we just treat it as an equation. Ohm's law says resistance equals voltage divided by current. And so V is voltage or potential difference, I is current, and R is resistance there. So if you can please write this down, make sure you get your units. We all know they're worth quite a bit. And then, yes, we shall carry on. Okay, so once you've written down that that equation, let's do some practice questions. So I'll pause the video and then I'll go through all the answers for you. Be the easiest way. Assuming everyone's had a go at that, you are working out number 1. You're working out resistance, which is V over I. V is 22.5, I is 5, equals 4.5. Now remember it's resistance, so you're working out and it's in ohms. Number 2, you're working out current, so that's V over R. V is 30, R is 10. 30 divided by 10 equals 3, and it's current, so it's amps. Number 3, what is the voltage cross component? So V equals IR. I is 2, R is 75. 2 times 75 equals 150, and its potential difference of voltage, so it's volts. It's a 5. It looks a bit more like a 3, doesn't it? Anyway, right, so you've now done a graph, or you did at the beginning of the lesson, about length versus resistance. And I'm hoping that when you did that, you saw that if we have length on the bottom, resistance here, hoping you've got a lovely straight line graph like that. Now, whenever you get a straight line, we can refer to it as directly proportional. So here you go, directly proportional. So clearly, length and resistance are directly proportional. So what I would like you to do for me, please, you can either write this on your graph or in your books, but you do need these notes, is add a little section about factors affecting resistance. Resistance is directly proportional to length. The longer the wire, the higher the resistance. Resistance is, and here's a new phrase, inversely proportional to thickness of the wire, the cross-sectional area. The thicker the wire, the less resistance. Now what, in fact, should we take a pause and just go directly proportional? If you double one, so if I doubled length, resistance also doubles. It's the easiest way of understanding directly proportional. Inversely proportional, however, is the opposite. If you double the area, because now we're looking at area and resistance, you halve the resistance. So if one gets bigger, the other gets smaller. You double one, you halve the other. So yes, once you've added that on, that would be fabulous. And that's it. That's all your notes for today. Thank you, everyone. Let me know if you have any issues.